Today we are going to discuss the procedure of selecting variables, explanatory variables and model building. Suppose we have x1, x2, xk explanatory variable now. See, this is our response y, and suppose this is the model. Now we see that if we explore all the subset, that means we get two to the power p, 2 to the power k. That is, if we consider only one explanatory variable, that means we have KC1 choices, if we choose two explanatory variables, then we have KC2 choices. If we choose three explanatory variables, then we have KC3 choices. So as a whole we get, and if you choose no explanatory variable, the only intercept term, then we have KC1 choices, KC0 choices. So as a whole we get so many subset or so many models, and using the criteria which we already discussed in our previous videos, we select best one among these 2 to the power k choices. But if k is very large, then it is very difficult to consider all these 2 to the power k models. So we need a systematic procedure. Today we will discuss a systematic procedure of selecting variables, explanatory variables and model building. The first method is stepwise stepwise regression technique. This methodology is based on choosing the explanatory variables in the subset model in steps, which can be either adding one variable at a time or deleting one variable at a time. Based on this, there are three procedures. Forward selection, backward elimination, stepwise regression. Here we mention that suppose we have k explanatory variables. In forward selection procedure, we discuss the steps. First, compute simple correlation coefficient between xi, y. We denote this by R xi y. Now find largest R xi y suppose R x1y greater than equal to R xi y, I from 2 to n, 2 to k. Then select x1. Now fit the model with y and x1. Now compute F statistics, denote this F naught, which is equal to n minus 2 into sum of square due to regression divided by sum of square due to residual, which is equivalently we can write it as n minus 2 times by 1 minus r square. Now choose fin. This is pre-specified value this is depend on experimenter or practitioner. So this ifn fin, which first we choose this value. Now if f naught greater than this pre-specified value, then x1 enters into the model. So if f naught greater than fin, then x1 enters the model. Otherwise, if f naught less than equal to fin, then x1 does not enter. Suppose x1 entered, then we have x2, xk explanatory variables, now we compute partial correlation coefficient of partial correlation coefficient between y and xi, eliminating effect of x1, and we denote it by r y I dot 1, where I equal to 2 to k. The procedure is first fit the model based on y and x1, then compute residuals now fit the model based on x1 and xj, and compute residual now compute simple correlation coefficient between E I or E, simply E means this y minus y hat, and E1j, that is x1 minus x1 hat. This gives partial correlation coefficient between y and xi, eliminating the effect of x1. So, using this procedure, we get k minus 1 such partial correlation coefficient. Then find largest partial correlation coefficient ry I dot 1 suppose it is ry2 dot 1, then consider y x1 x2, that is y is a response variable, x1 x2 is explanatory. Now compute partial F statistics, which we discuss in our fourth video, that is F equal to sum of square due to regression x2 given x1 divided by mean sum of square due to residual using both x1 x2 equal to sum of square due to regression x1 x2 minus sum of square due to regression x1 divided by sum of square due to residual x1 x2 into n minus 3. If this partial F statistics greater than Fin, then x2 enters into the model. Otherwise, we x2 does not enter into the model. Similarly, so now we have x1 x2 and x3 x4 xk. These x1 x2 are already entered into the model, and these are remaining explanatory variables. Now again we compute partial correlation coefficient of y and xj between y and xj, eliminating the effect of x1 x2. We denote this by r yj dot 1 2, where j equal to 3 to k. And find the largest ryj dot 1 2, and then we compute partial F statistic. If partial F statistic greater than x2 greater than Fin, then we enter the new explanatory variable enter. So we repeat this process or steps until partial F statistic less than fin. So we again repeat whole process one by one. First we compute, first suppose we have k explanatory variables x1, x2, xk, and y is a response variable. First we compute k simple correlation coefficient between y and xi, then find maximum correlation coefficient. Suppose the maximum correlation coefficient occur in x1, then we start with y and x1, then we fit the model using y and x1, then compute f. Now choose p specified value fin. This is depend on the experimenter. If f statistics greater than fin, then we select x1 or x1 enters into the model. Now if x1 enters into the model, then we have only x2 to xk explanatory variables. Then we compute partial correlation coefficient between y and xj, eliminating the effect of x1, then find maximum partial correlation coefficient. Suppose it occur in x2, then you compute partial f statistics. If partial f statistics greater than fin, then x2 enters into the model, otherwise x2 does not enter into the model, and we stop the process. If x2 enters into the model, then we again compute partial correlation coefficient between y and xj, eliminating the effect of x1 and x2, and then find maximum partial correlation coefficient and choose the variable where these things is happen. Then again compute partial f statistics. If partial f statistics greater than fin, then we select this new variable, or this new variable enter into the model, other we stop. So in this process we repeat this process and stop until the partial f statistics less than fin. This is all about forward selection procedure. Now we consider backward elimination procedure. We begin with all explanatory variables and keep on deleting one variable at a time until a suitable model is obtained. That is, here we consider all explanatory variables and keep on deleting on the variable at a time until a simple model is obtained. The steps are: first we consider all k explanatory variables. Then feed the model. Now compute partial F statistic. That is, suppose we have k explanatory variable, then we denote fj. This is a partial f statistics, so this is equal to sum of square due to regression xj given x1, xj minus 1, xj plus 1, xk. That is, here we interested the effect of xj, only the effect of xj. So divided by sum of square due to residual into n minus k minus 1. And this j varies from 1 to k. So we get k so many partial F statistic. Now, if smallest fj less than f out, this is again a pre-specified value. This depends on experimenter choice. So if fj, smallest fj less than f out, then we remove the corresponding explanatory variable. That is, suppose f1 is minimum over j and if f1 less than f out, then we eliminate or remove x1. Therefore, the model will have now k minus 1 explanatory variables. Again feed the model with this k minus 1 explanatory variables and then compute partial f statistics for new model and then find minimum partial f statistic, and if this minimum partial f statistic less than f out, then we remove the corresponding variable. Suppose this happened in, for example, suppose this happened in we take j from 2 to k. For example, we assume that in step 1 x1 eliminated. That means f1, in that case f1 is minimum and this f1 less than f out, then we remove x1, and in that case the new model consider only k minus 1 explanatory variable, that is from x2 to xk, and then we compute partial f statistics for new model, and suppose the partial f statistics minimum corresponding x2, and if this f2 less than f out, this is p specified value, then we remove x2 and stop the process. When smallest partial f statistic f greater than f out. So the process is, first we consider all explanatory variables, then compute partial f statistics for k variable, and then find minimum f statistic, minimum partial f statistic. If minimum partial f statistic less than f out, which is pre-specified value, then we eliminate or remove corresponding variable. Then next step we consider model with k minus 1 explanatory variables. Again we compute partial f statistics for k minus 1 explanatory variables, then find minimum partial f statistics. If this minimum partial f statistics less than f out, which is a pre-specified value, then we drop or remove the corresponding explanatory variable, and we continue this process. Where the smallest f statistic less than greater than f out, that means we stop the process until we the situation when the smallest step statistic greater than f out, f out is a pre-specified value. This is depending on experimenter choice. Now we consider now we discuss third method, stepwise selection. Using forward and backward method, we select explanatory variables. So step 1 is consider all the explanatory variables entered into the model using previous step, that is forward and backward elimination. Second, add a new variable and compute partial F statistic if partial F statistic less than F out, then new variable deleted from the model. Here we mentioned that we need for this method F in and F out. Sometime F in equal to F out, or sometime F in greater than F out. If F in greater than F out, this makes relatively more difficult to add an explanatory variable than to delete one. Now we consider some points. Note 1. The order in which the explanatory variables enter or leave the models does not indicate the order of importance of explanatory variable. Note 2. In forward selection, no explanatory variable can be removed if entered into the model. Similarly, in backward elimination method, no explanatory variable can be added if removed from the model. Note 3. All procedures lead to different models. Note 4. Different model selection criteria, which we discussed in our previous video, like Malloy's CP, SS due to residual, MS due to residual, adjusted R square, partial F statistic, etc. Different model selection procedure or criterion, rather it is better to say criteria. Different model selection criteria may give different subset model. Note 5. And it is very important note, none of methods among forward selection, backward elimination, or stepwise regression guarantees the best subset model. That is, none of the methods among forward selection, backward elimination or stepwise regression guarantees the best subset model. This is very important note. Last note, the choice of FIN, Fout. Generally, we choose FIN equal to Fout very close to F 0.05 1 comma n minus 2 or approximately 4. So most of the situation, or you can choose FIN equal to Fout equal to 4. Otherwise, experimenter or practitioner may provide this value FIN, Fout depending on their requirement. These are all about variable selection and model building. Hope you enjoy these classes, and this is homework for you. Please, using this algorithm, create a code using R, Shash, Python or any other statistical packages regarding this model building procedure. This is stepwise procedures, and you can use this pre-specified value for FIN, Fout. This is your homework, and please stay with us. We will come very soon with a new topic, that is generalized linear regression. Thank you.